All right, hello everyone. I see a few of you are logged on here. We're going to see if anyone else decides to tune in. If not, the video will be up here. Tell everyone to watch the video. Should be a good, helpful review. I'm just going to start from number 1 and kind of go through some of these, and I'll point out little things that you might want to put on your reference sheet for the test and things like that. And then make sure to just put in any questions you have in the comments, and I can see them here and I can answer any questions that come up as I'm going through some of these problems. So for the first one here, we have q of t. So we want to find what q of n minus 1 is. We're not multiplying q times n minus 1. What this notation means is it's naming the function. So it's saying take the function q and plug in n minus 1. So this function notation, you can have different names for different functions, and whatever is next to it in parentheses is the variable that you're plugging into it. So for example, here we have q of t, so the variable is t for the function q. This notation means plug in n minus 1 to the variable t. So every time I see a t, I'm going to change that into n minus 1. So I have 5 times n minus 1 squared minus n minus 1 plus 3. Whenever I have something being squared, I'm not going to distribute it. We cannot distribute like that. We have to actually take n minus 1 and square it, which means we have to do n minus 1 times n minus 1. It's not the same thing as just distributing that square and making it n squared minus 1 squared. Can't do it that way. So we have to FOIL this out. N times n is n squared. N times negative 1 is negative n. So that's those two. Then we're going to multiply those two as negative n again. Negative 1 times negative 1 is positive 1. So together we have n squared minus 2n plus 1. So I can go ahead and replace this part right here with what I just found. N squared minus 2n plus 1. This minus is going to distribute into both of those terms. So that's going to become minus n plus 1, and then I have the plus 3 there. So this 5 has to distribute into the parentheses. That'll become 5n squared minus 10n plus 5. I still have the minus n plus 1 plus 3. And now it's just a matter of combining like terms. So there's no other square terms. I have a negative 10n and a negative n. So those are going to become minus 11n. And then plus 5, plus 1, plus 3, that's going to give me plus 9. So that should be our complete answer there once we've distributed everything. So that's number 1. We should be able to find, we're calling this evaluating it because we're plugging in something to a function, but it's also a combination of functions. So for numbers 2 through 4, we're just finding the different parts of the trig function. So the amplitude is the number, the absolute value of the number right in front. So the absolute value of negative 2 would be positive 2. The period of a cosine function and a sine function is 2 pi over the absolute value of b. b is the number that multiplies x. So in this case, our b is 4. So our period is going to be 2 pi over 4, which is going to equal pi over 2. And then for this last one, we're going to determine the shift of this function. Doesn't say vertical or phase shift, but if you look here, there's actually no phase shift. We're not adding anything inside the parentheses. So it's really just our vertical shift, which is negative 3. Okay, so that takes care of 2 through 4. Number 5, we're finding the period of a tangent function. So instead of 2 pi, like sine and cosine, tangent period is going to be pi divided by b, or the absolute value of b. In this case, our b is 2, so our period is going to be pi over 2. All right. Number 6, we need to find the equation for this function. So you need to make sure that you are familiar with all of the parent functions that we went over in the beginning of the school year, because that way you can come up with equations as long as you know the parent functions. So if you look at this, this is the absolute value function, which means the equation of that is y equals absolute value of x. It looks like that with the 2 lines. And the original function looks like this. So it goes through the origin, has a slope of 1 on both sides. Looks like a V. So if we see here in the green, the original one has been flipped over. So it's been flipped over the x-axis. We show that as a negative in front of the parent function. So by putting that negative now, we've turned the parent function to something that looks like this. So it's the same thing, it's just been flipped. And now to account for it moving down, we need to give it a vertical shift of 1, 2, 3, 4. So that's just going to be minus 4. So if you look at this equation now, we have the reflection, and then we have the vertical shift that brings us down to that green graph there. So you want to be familiar with the functions. One of them is the absolute value function. Other examples could be your square root function, the square root of x, and that looks like that function there. You might want to, well, you definitely want to know x squared. That's the parabola. X cubed. That's looks like that. It's kind of like the tangent graph. And you always want to use these points that are centered at the origin to help you decide on the vertical shift and whatnot of each of those parent functions. Then we also have the more basic functions, the one that's the just the line, that's y equal x. And then your last one was the constant, which is just any number, y equals 2, y equals 3, whatever it is. I'll just call it C for constant. So those are your parent functions that you want to be familiar with. And so any of those kinds of transformations might come up on the final. Number 17, we want to express 112 degrees in radians. So I'm going to have to multiply this by pi over 180, because that is how we get our, we change from degrees to radians. So we have 112 times pi over 180. And now what I want to do, this just becomes 112 pi over 180. But I need to simplify that part of the fraction. The pi we can't really simplify, but 112 over 180 is going to equal 28 over 45. And then I just put that pi there. So that is now 112 degrees in radians, 28 pi over 45. Numbers 8 through 9, we're using the function that got cut off here. Let's see if I can remember. I want to say, correct me if I'm wrong here, I think it goes to like positive 4, and that's where the parabola starts. I don't have another copy of this, so I'm not quite sure where this goes, but we're going to say it starts at 4. So to find the domain, we need to think about all of the x values that the graph spans. And so if you look here, this graph is going to keep going and going and going in both directions, which means that no matter what x values we go out to, it's going to reach negative infinity and positive infinity on both sides. Thanks, Fernando. Okay, so it is 4. Cool. And hi, by the way. Thanks for tuning in here. So our domain is going to be all real numbers because all of the x values are going to be part of our domain. So we can write it like that. That's the symbol for all real numbers. Or you can say it's going from negative infinity to positive infinity. So that could be another way that you write it. For the range, that's where this 4 comes into play, because we have to look at the x-axis and see, or sorry, the y-axis, and see which of these values here are part of our graph. And we see that all of these y values, all of the negative y, and everything from 0 to 4 is not included, is not part of the graph. So our range has to be y greater than or equal to, because we do have a point at 4. So you can write it like that, or we can write the other notation, which we have to go in order from smallest to biggest, just like we did here, negative infinity to positive infinity, that's in order. So 4 is the smallest y value, so that's going to come first, and I'm putting a bracket here because we need to include 4, and then it's going to go to positive infinity, and that's got to be open because we can't really close in on infinity, so that's always going to be open there. And that's going to be our range. You should be familiar with both notation because remember your test is multiple choice. So your choices might be written like this or they might be written like this. So you got to make sure you know and can understand both ways. So that you can expect domain and range to be on the test. And we have inverses. So to find inverses, you always want to think switch x and y. So our y is this f of x value here. I'm going to switch that with the x's on the other side. This will become x is equal to 2y minus 1 over y plus 3. So to find the inverse, we need to solve for y now. The best thing, what I'm going to do first is not make this a fraction anymore. So I'm going to multiply by y plus 3 to both sides. So then those y plus 3's are going to cancel on the side where the fraction is. And we're going to multiply this x through on this side. So xy plus 3x equals 2y minus 1. That's all I'm left with there. And our goal is to isolate y. So what that means is anywhere I see that I have a y term, I need to combine them on one side. Pick a side, doesn't matter which side you pick, just move them all to that side. So I'm going to take 2y and subtract it from both sides. So minus 2y on this side, minus 2y on that side, so that I can take it away from that side and move it over. So I get xy plus 3x minus 2y equals negative 1. And then I'm going to do the same thing with this 3x because it doesn't have it doesn't have a y, so I don't need it on that side. I want it on the other side. So I'm going to subtract 3x on both sides. So we have xy minus 2y is all I'm left with here equals negative 1 minus 3x. So I really just went ahead and switched these two, moved them on opposite sides, because now I have my y's here. And what I can do with those y's is I can factor it out. I'm left with y times x minus 2 equals negative 1 minus 3x. And I can divide by x minus 2 on both sides. That cancels out. I get y is equal to negative 1 minus 3x over x minus 2. If I want to, I can rewrite this now and relabel it as my inverse function now. equals negative 1 minus 3x over x minus 2. So that will be my solution there. Make sure and let me know, for those of you who are watching, if you have any specific problems that you want me to get to, because I may or may not be able to get through the whole thing, but at least I get to answer any questions that you for sure want to see done here. So number 11, we've been given the radius of a circle is 5. We want to know what is the length of the arc that subtends an angle of 13 pi over 20 radians. So I'm going to move all this work that I just did for the inverse function. Move it over here so I can have space here. Let's do purple. And so we need to know the formula for arc length. We have S represent arc length, and that's going to equal R times theta. So this is our arc length. This represents our radius, and this represents our angle. So you just need to know what each value represents, because then the question is going to give you what each of the values is, and it's also going to tell you which one you need to find. So you plug it into the correct ones, and then you solve for the correct one. So the radius is 5, so I'm going to plug that in for R. What is the length of the arc? That means we need to figure out what S is, so I'm going to leave that as the variable. And it says the angle is 13 pi over 20. So, lucky for us, it's already solved for the variable we're looking for. So all we need to do is 5 times 13 pi over 20. Well, this is going to cross simplify, because that's technically over 1. 5 times 1 over 20, that's going to simplify to 4. So I get 13 pi over 4. Simple as that. You could have gone ahead and multiplied straight across. 5 times 13 is 65 pi over 20. And then you would have had to simplify that. 65 over 20 simplifies to 13 pi over 4. So that gives us the arc length that we were looking for here. Number 12, we need to divide. So I see that we're dividing by x minus 2. That means that I can use synthetic division. All I have to do is, if we're dividing by x minus 2, then a positive 2 is going to go in the corner here. And then I need to make sure that I have my terms in order by degree, and then just put the coefficients of each. So I have 1, negative 3, negative 5, and I'm missing an x cubed. So I need to put a 0 here, and then 29. And I'm missing, oops, I didn't mean to erase that. I'm missing an x term. So I need to put another 0, and then minus 4. So I've got that. Now I'm just going to do the synthetic division. Bring down the 1. 1 times 2 is 2. Minus 3 is negative 1 times 2. Just keep going. That's negative 14. Gives me negative 14 times 2 is negative 28. Gives me positive 1, 2, 4, and 0. So my remainder is 0, which is nice. So that means that x minus 2 is technically a factor. We're not really looking for that in this question, but just pointing that out there. So our answer, we have to start 1 degree lower from where we started with. So I'm going to have x to the 5th minus x to the 4th minus 7x cubed minus 14x squared plus x plus 2. And that is, that is our answer here, using synthetic division that is given here. So remember, the amplitude is the distance from the midline to the highest value. So I need to figure out what is the of this graph here. I see that it spans between these 2 points here from negative 0.5 or negative 1/2 to negative 1.5 right here. So that creates a distance of 1. So half of that means we have a amplitude of 1/2 or of 0.5. So that's what my amplitude will be in this case. A is equal to 0.5. So it's the distance from the midline, and you can see here the midline that has to be the same distance anyway. So that is a distance of 0.5. This is a sine graph. So I know I'm going to be writing out the equation of sine. I'm just going to do like the standard part here. A sine bx minus c plus d. And what I want to do next is just find each of the parts. So just like we did before, we were able to find the amplitude. I'm going to look here. I know my midline is right on the axis, which is nice. And then I can see that my amplitude is 2. So that A can now be 2. Also, because we're starting right here at the origin, I know that there hasn't been a phase shift. It hasn't been moved over or anything. So that means that this is just going to be 0. We're not going to have any C there. So I'm not going to bother writing that again. I know it's a 0. Also, if our midline is on the axis here, then I can go ahead and say that my D is 0 also. So I don't have to add that in or anything. Really, all we have left to figure out is what is our B. So the B has to do with our period. The period is the distance that it takes for our graph to do one full cycle. So remember we said it's starting here, then we go up, middle, down, middle. That took a distance of 2 pi. From this 0 all the way to the end, that's a distance of 2 pi. So that means our period is equal to 2 pi. Well, how do we normally find the period? Period is 2 pi over b. So I'm going to set that equal to 2 pi because that's what we said the period is. What does that make our b? Well, it means our b has to be 1. And why is that true? Well, we can solve if we want to. I can cross multiply these. That'll give me 2 pi b is equal to 2 pi. And then when you divide by 2 pi here, we're going to get b is equal to 1. So our b is 1. I don't technically ever really need to write that there because 1 times anything is just itself. So our equation is 2 times sine x. We didn't have any reflection because it goes from the middle up. So I don't have to put a negative out in front. All right. 15 says, suppose the angle A terminates in quadrant 4 and sine of A is equal to negative 3/5. We want to find tangent A. So this is giving me 2 key pieces of information. First of all, it's telling us that the quadrant, or what quadrant our angle is in. So I'm going to draw that angle right in quadrant 4, which is down here. And I'm going to draw it as a triangle. So close it up, going towards the x-axis. And what did we call this angle? This is angle A. So I'm just going to call that angle A. We're dealing with the triangle here, so we're going to use SOHCAHTOA. This is our opposite side. This makes this our adjacent side and our hypotenuse. So once we have that set up, we're going to jump back here to this piece of information that they said sine is negative 3/5. So we know that to find sine, it's opposite over hypotenuse because of SOHCAHTOA. So I'm going to come over here, label my opposite as 3 and my hypotenuse as 5. Now the next thing I have to figure out is which one is going to get the negative. Well, it's nice here because the hypotenuse always has to be positive, so that means the negative has to go to the 3. But another thing that you could have thought of is what axis is positive or negative in this case. And so this is our positive side of x, but this is our negative side of y. So that means that this value that's going along the y-axis has to be negative. So that 3 is going to get that. Once we have 2 of the sides, we want to use Pythagorean's theorem to find the third side. So we can set that up. Negative 3 squared plus b squared equals 5 squared. And we're going to get b is equal to 4. It's also just a 3, 4, 5 triangle, so many of you probably already knew already it's going to be 4. And it's got to be positive, because remember it's on the positive side of the x-axis. So we have those 3 sides. If we're trying to find tangent, tangent is opposite over adjacent, which means it's going to equal negative 3 over 4. And that's our answer. So remember, be careful where that triangle is going to land. Let's say it lands in this quadrant here. In this quadrant, this is the negative side of x, and it's also the negative side of y. So that means that both of these values, whatever ends up here and whatever ends up here, those would both have to be negative. And then remember, your hypotenuse is always positive. So keep that in mind as you are drawing in the triangles. Remember, they're going to tell you different quadrants, and it's up to you to figure out that's going to land and what is going to be positive and negative in each of those quadrants. So, like for example, in this one, if your triangle was going to land in the second quadrant, then this right here would be negative, which we said earlier, but this y would be positive. And the hypotenuse, again, would be positive. So keep that in mind. You don't want to forget to change those negatives and positives when you're going through problems like these. 16 through 19, we have to use the unit circle. Let me see if I can actually